What we have here are 4 different types of liver. So the first thing you need to do is to make a data table so you can record your observations about these 4 types of liver. Okay, so the first type is just raw liver. Okay, and you guys can kind of look at it. It's a little bit more pink than the others. Yeah, and it smells like liver. Okay. So that's raw liver. Any guesses for why I am going to use raw liver?
As a control.
As a control. Very, very good answer. Clap. All right, this next one is liver that has been soaked in a base. So I started out with raw liver and I poured sodium hydroxide on it and just let it sit.
So can I put like base liver?
You can put base liver. Okay, so this is liver that has been soaked in a base. And you can tell the color is a little bit different. Alright, this next one is liver that has been soaked in acid. So same idea, I took raw liver and then I poured acid on it. I poured HCl on it. And then this last one, again, same idea. I had raw liver. This time I boiled it. So I just put it on a hot plate and let it boil away. Huh? You chop up liver, put it in a blender, you add water.
Ew.
There you go.
You burn the blender.
My dream meal.
That's how, if you guys remember, this is liver left over from the organisms in pH lab.
Really likes her liver.
Alright. Okay, this is hydrogen peroxide. So I'm going to pour this in here. Oh, before I do anything, make sure you write observations about how the liver looks now.
Oh, so that's like
Because once you record what it looks like, we'll add hydrogen peroxide to it, and then you guys will have to decide what has happened to it.
Can you like move it to where like,
H2O2. Good question. Can I do what?
can you like move it to where like I can see all of it?
Like closer to me so you can...
No, but like just on a
Like
disc.
Yeah,
Like,
I can. I will in just a second.
look at it. You can smell it.
Oh, I'm not smelling
Don't smell it. I would not.
Did that help?
that. Isn't that like your dream meal right there?
They're different shades of
Orange brown.
like they all.
Wait, I can't.
Yeah, this one, I don't know if you guys saw it when I brought it out of
BEIGE.
the refrigerator, but it had separated, and this was really red at the bottom, kind of bloody looking, but I mixed it all up. So it's a little bit more pink than the others.
Wait, which one's which?
Raw,
Raw?
base, acid, boiled.
Little pebbles. What are those little dots?
That's just look like from the meat of it, it's starting to separate again.
Raw, base, acid, boiled.
Is like a darker brown, right?
Yeah, and then I put like acid's very liquidy, and then the boiled one is beige.
Okay,
BEIGE.
remember that this has to do, or this topic has to do with enzymes, right?
Right.
Anybody?
Yes.
Okay, so this has to do with enzymes. So liver contains what? Enzymes. So your body has a liver, right? What does your liver have? Enzymes. Huh? Okay. So enzymes are really important for reactions in your body to occur, right?
Yes.
Okay, so what I have in here is the hydrogen peroxide that I just poured in, right?
Yes.
Again, hydrogen peroxide is H2O2. And so I want you to see what happens when I add hydrogen peroxide to each of these. Okay, before I start, any guesses on what will happen when I pour hydrogen peroxide onto the raw?
Decompose.
It's going to explode. It's going to dissolve. Break it down. You think it's going to bubble? Bubble?
Yeah.
Alright, so are you guys ready? Here we go.
Reese's bubble.
Ooh.
Oh.
Ah. Alright, well, if I poured more on, what would happen?
It would go overflow
And why?
because it would be more.
Chemical reaction.
What's still in the liver?
Enzymes.
Enzymes. Do enzymes get destroyed by a reaction?
No.
No, they can be used over
And over again.
and over. Alright, so I'm going to let somebody hold this, okay? Because I want you to feel the difference between one that has a reaction happening and one that doesn't.
Is it warmer on the reaction?
Smell it while I try that Morgan.
How does it feel?
The same.
Somebody else.
This one's warmer.
This one's warmer. You want to try?
Warmer.
Wait, which one?
I'm gonna put
Do you feel it?
on all of it.
I don't feel it.
No, I don't. I take that back. I work with my
Yeah, that one's warmer.
This one's supposed to be warmer. I really feel
I
it.
guess a little
Can I
bit.
try
A little
one?
bit. Yeah, it's not going to be a huge difference.
Oh, yeah.
You feel it now?
A little bit.
Alright, so
It's not warm.
I'm gonna make
It's
sure I
not
put it back.
cold.
Yeah.
Right, it's not hot. But what do you
Yeah.
call a reaction that releases heat? Wait, what? Exothermic. So this reaction is an
Exothermic.
exothermic reaction, and it bubbled and fizzed, right? Okay, are you guys ready to see what happens when we put it on base? On a base? I'm gonna take that as a yes.
Yeah.
Alright, here we go.
Same thing.
That's the same thing.
Is it as big as this one was? Okay. Okay, so make sure you.
Is it still
Write
an
that down.
exothermic reaction?
Sorry.
Alright, what do you guys think will happen with the acid? I mean, it's an acid, right? What do you guys think?
It's gonna explode.
Do you think it's going to be greater than these two? What are your thoughts? Huh? What are your thoughts? What do you guys think?
Maybe we would just do the opposite.
Why would it do the opposite?
I mean, I really can't explain it, but I'm just thinking if for the base it bubbled, and then for the raw liver it bubbled. I don't know what the pH is for that, but maybe we'll just do the opposite.
Unless the acid is an inhibitor, it really shouldn't slow it down. So.
Okay. Anybody else? So what if the acid is an inhibitor?
I mean, the change in pH could slow it down.
Okay, so let's see. She said the change in pH could slow it down. Shh. Here we go.
Oh, nothing.
Yes, I did.
Well, it swirled, but why did it swirl?
Because it was a new liquid.
Because I
Physics.
squeezed the stuff out of it, and so the pressure of it made it swirl. So really no reaction, right?
Yes.
This is hydrogen peroxide.
Alright, last one, boiled. What do you guys think about boiled? What's gonna happen? Nothing?
The same as those.
The same as these two?
No reaction.
What'd you say, Clark?
Didn't that like already tell us what was gonna happen in another lab?
Did it?
Because the boiling got rid of the enzymes.
Let's see what happens. I like his answer. Ready?
Mm-hmm.
Oh my god.
Absolutely nothing.
Nothing.
It released the smell.
There was no reaction. Alright, so we need to talk about why these reactions happen. Why did the raw bubble and fizz so much? It had enzyme. Where's the enzyme?
In the liver.
In the liver. So what is the hydrogen peroxide then?
Substrate.
The substrate. Okay, so we added the hydrogen peroxide to the liver. It bubbled and fizzed because the liver had
Enzymes.
enzymes. All right, we'll come back to the base one in just a minute. The acid one, there was no reaction. All right, when we added hydrogen peroxide to the raw, it bubbled and fizzed. It did nothing here. So what's missing?
Maybe it wasn't
The enzymes.
maybe it wasn't like the lock and key type of thing where it just doesn't fit into it. So
Why would it not fit into it?
Competitive
Denature.
inhibitors.
Denaturing. Very good. So when I added the acid to the liver, what did it do to the enzyme? It denatured it. So if this is your enzyme and this, or the liver enzyme, and this is your hydrogen peroxide, it should interact and then change into product. But what happened to this when I added acid?
Shriveled up.
It changed shape. And so can this interact anymore? No. All right, what about the boiled one?
All the enzymes are boiled away.
They're boiled away. So same thing. What's that word? Denatured. All right, so then we come back to this one. This one's kind of troublesome, right? Now that we know what happened here, what would you expect if you added a base to liver enzyme? What would you expect it to do? Denature, right? If you add acid and you boil it, extreme pH or boiling, high temperature, you would expect that to happen here as well, right?
Mm-hmm.
However, I used a very weak base on purpose, right? What else does our liver have that could allow this to still react?
Buffers.
Buffers.
Very good, Kari.
You said that.
Sifa was there with me.
Very nice.
Don't record me.
All right, so this liver enzyme, when I added the base to it, was a weak one. The liver had the buffers to resist the change in pH. So, are there still enzymes here?
Yes.
Are there as many enzymes as there was in the raw? No. So the reaction was not as great, but you still saw some because the buffers resisted that pH. Cool? Okay, one more question. What are the bubbles?
Oxygen coming to the surface.
Oxygen, right? So when you add hydrogen peroxide, which is H2O2, to the liver, what are your two products that you're going to get?
Water and oxygen.
Water and oxygen. So have any of you ever had a cut? Yes. Anybody put hydrogen peroxide on it?
No.
No, it doesn't.
Alcohol burns.
Yeah, so if you cut yourself and you put hydrogen peroxide on, what do you see? It bubbles. Why is it bubbling? But what is exposed when you cut yourself? Blood. What's in your blood?
Buffer.
Enzymes. So when this hydrogen peroxide touches the blood, which has enzymes, it's going to bubble and fizz. What's the bubbles? Oxygen. What is the liquid that's running down your arm? Water. Cool, right?
Water is produced when it reacts with the.
I thought she was going to say
Yeah.
blood.
Okay, so what I need you guys to do, we only have a few minutes left, but now that you've recorded your observations, you need to go back and answer the questions in the lab and write a conclusion about it.
For homework?
Yeah, you will have to finish that for homework.